In the 21 hours of Tableau course, I have sketched more than 150 sketch notes. So what I have done, I've collected all those animated visuals and put it in one video for you. And lately I've got a lot of questions about how did I create all those animated visuals? Well, I was creating them using my tablet and as well using the app Procreate. I was really inspired from Tim. He has one amazing video about what is Tableau and he used sketchnotes using the Procreate. That's why I went and downloaded the app and start sketching from the scratch. So I have no skills before on how to sketch those visuals. And if you don't know already Tim, he is an amazing guy. He makes really great content about Tableau. Alright, so now let's go and deep dive into the animated videos of Tableau. The amount of generated data every day from IoTs, social media, websites, machines is truly mind-blowing. There are currently over 44 zettabytes of data in the entire digital universe. That is 21 zeros. So that means we are no longer dealing with normal, traditional data. We are dealing now with the big data. So what big data means? There is 3 indicators that help us to understand whether our data is big, and they are defined by the 3 V's. The first V is volume. Well, big data is big. With the growth of the internet, mobile devices, social media, IoTs, the amount of generated data from those sources has grown dramatically. The second V is velocity. In normal data processing, we used to process slow data, or we call it batch data, once a day or something, and then we store it in the disk. But in big data worlds, the sources are generating streams of data with very high speeds. That means we have to process and analyze the data in real-time fashion, and then we store it in memory instead of disk. And the third V is variety. In traditional systems, most data types could be captured in raw, unstructured tables like database or Excels, but in the big data worlds, data often comes in semi-structured format, for example, server logs in XML or websites, or the data comes in unstructured format like videos, audios, images, free text. So in big data, we have not only to deal with structured data, but also with semi-structured and unstructured data. So what we can do, we can design or build a data architecture. Data architecture is the process of creating a blueprint on how we organize, process, and store our data into different layers for different purposes. So data architecture makes it easier to manage, protect, and access our data. Another thing that we can do with the raw data is data engineering. Data engineering is a very complex process of designing and building data pipelines and data storages. In data engineering, we usually build ETL processes to extract the raw data from multiple sources, then transform it and then load it to the target storage in order to make it highly available and usable for the data scientist or any other end user. Another thing that we can do is data modeling. So data modeling is the process of connecting the dots. So what we're gonna do is we're gonna put all the data into entities and objects. Then we describe the relationship between those entities in order to help us and help the programs to understand how the data are related to each other. Another thing that we can do with the raw data is we can do data mining. Data mining is the process of analyzing massive amount of raw data in order to discover knowledge, to discover business intelligence like patterns and trends, to solve problems and to mitigate risks. Another use of the raw data is that we can use it in machine learning. In machine learning, we are providing the computers with 2 things. First, the raw and historical data, together with the mathematical models and algorithms. So once the computer has those 2 things, it's gonna start training and practicing in order to perform tasks like predictions. So it's like human, the more the machine practice and train, the better and accurate the result's gonna be. And next we can do data science. Data science is the scientific study of data, and it combines 3 major powers. The power of programming languages, together with the mathematics and statistics, and the knowledge of specific domain, in order to uncover valuable knowledge and insights from our raw data. One more thing that we can use on the raw data, and my favorite one, is that we can use data visualizations. So data visualizations is the process of converting numbers and raw data, which is normally hard to understand and to read, into visuals and charts like bars, pie, tree, plots, in order to make it easier to understand and easier to read, which really helps in the decision making. There are many other things and processes that we can apply it on the raw data, but these are the major fields of work that we can use in order to convert the useless raw data into knowledge that has significant impact and value to the business. Alright, let me tell you this story. We have shops in 3 different cities in Germany. In Stuttgart we have shop, Berlin and Hamburg. And our 3 shops are generating every business day a lot of raw data on sales, inventory levels, products, staff, costs and so on. And now we have a group of people that are the decision makers, like managers, HR, finance, and they have many questions and decisions to make. So they might have questions, for example, what happened? And another questions about what will happen. Now, if the managers try to find the answers from the raw data, they might find nothing and no answers, because the raw data are usually very complex and badly structured, and they are really hard to understand. And that's why they're gonna go and hire some data analysts, for example, in order to help them finding the answers from the raw data. So the data analyst gonna go and start analyzing the raw data by doing some magic, for example, cleaning up the data, connecting objects together, and aggregating the data in different levels. And at the end, the result will be communicated as, for example, spreadsheet to the decision makers. And in the other hand, the managers can hire data scientists in order to help them finding answers about what gonna happen or uncover unknown facts and insights. So the data science gonna as well go and start analyzing the raw data, but this time using different methods, like for example data mining, machine learning, or train a model, in order to find new insights, new knowledge, and answers to the questions. At the end, the output gonna be communicated as well to the managers as numbers and spreadsheets. Now, both of the data scientists and the data analysts did an amazing job working on the raw data and analyzing those stuff. But the problem here is that the output might be hard to understand and to read, because those managers are usually people that don't work directly with the data every day. So this could lead to a big gap between those managers and the results. And now, in order to bridge this gap and make everything easier, we can use the power of data visualizations, and the result presented from the data scientist and the data analyst should be converted from these boring numbers and spreadsheets to visuals, graphs, and charts. The visual representations of the data will just do the magic by making everything clear and easy. And it's gonna bring very easily the wow effect once you are presenting your results. So it's gonna help the managers to immediately find their answers, and they're gonna start making decisions using the data. This process, we call it a business intelligence, or as a shortcut, BI. If we see a tree, our brain gonna store it as a visual, as an image in our brain. Studies say that 90% of the information transmitted to our brain is visual. But if we read the word tree, our brain has failed to transform it to a visual before storing it, which is way slower. In fact, the human brain processes visuals 60,000 times faster than a text. More facts about our brain is that we remember most of what we see and interact with. It's proven that the human remember only 10% of things we hear and 20% about what we read, and it's also proven that we remember about 80% of what we see and interact with. There is around 1 billion users globally are using Microsoft Excel. I worked in many companies, and I can tell you, people are just addicted to Excel. They love it. They use it for everything, as planning tool, data entry, data analysis, and data visualizations. But the main problem here is that the more a company grows, the more it generates data, and because everyone is familiar with Excels, they're gonna keep using them in big data use cases, and they're gonna face really hard time managing those spreadsheets and dealing with the limitations in Excel. In these situations, it's really time to switch to a modern BI tool or data visualizations tool like Tableau or Power BI. Now let me show you how BI is done with Excel. We usually have different source systems and a data analyst that's gonna go and start exporting manually the data from those systems and import them in Excel. And then some calculations gonna be done, and at the end a report will be generated. The Excel files then will be accessed from different business users. In the other hand, we can do BI with a modern tool like Tableau. So what we're gonna do, we're gonna connect Tableau directly to those source systems, and the data analyst gonna start developing a report or dashboards in Tableau. And at the end, the business users will access Tableau in order to see those dashboards. So far, you can say, okay, both look really similar. So now let's dive in order to show you what is the real benefit of having a modern BI tool like Tableau or Power BI, and the limitations that we have in spreadsheets like Excel. The first benefit is automation. If you are using Excel and we made some nice reports, it's time now to update the data. And how we do that in Excel? We update data manually. So some employees have to sit down every day and go through the process of extracting data from those source systems, importing them in Excel, do calculations, and at the end prepare the reports over and over again, which is very time consuming. But if you are working with a modern BI tool like Tableau, we can automate this boring task by creating schedule to refresh the data. For example, we can create a schedule in Tableau every day at 7 o'clock morning. Tableau should automatically connect to the data sources, pulls the data, and prepare the reports. There is two benefits of doing that. First, we eliminate the human errors, which is very common thing in Excel, and sometimes those mistakes can lead to wrong decisions and to finance loss. And the second benefit, of course, we no longer need employees that is dedicated only for this boring task of exporting and importing data manually to Excel. Another benefit here is the capacity. If you are working with Excel and one of our source systems start producing and generating massive amount of data, here we have problem in Excel because we can handle around only 1 million records. So our Excel file gonna breaks and we're gonna start getting error messages like the data set is too large. So what we usually do in Excel, we're gonna go and start splitting the main file into small multiple files in order to manage the huge volumes of data, which is really hard to manage. In the other hand, if you are working with Tableau, we don't have to worry about all those stuff. We have no problem in Tableau because Tableau is made for big data use cases and can very easily handle massive amount of data. So we might just change the connection type from extract to live in order to handle it. Another benefit is security. If you are working with Excel, it's really hard to hack into Excel. Even if you are using password-protected spreadsheets, it still can easily hacked nowadays. And the users are really used to share their Excels in emails, copy it to USB or store it locally at their computers, which is not secure at all. So all those stuffs could cost the companies a lot if sensitive and confidential data is accessed by competitors. But if you are working with modern BI tool like Tableau, it's gonna provide us with superior security features like advanced access control, data security, network security, and plus if you are working with Tableau, we don't have to export the data. We can just share the dashboards and reports between employees, and only if we grant them access rights, they can see the data. Another benefit is the row-level security. In many companies, they have a lot of confidential sources, and they start to understand how important it is to apply the principle need to know. The principles needs to know says, a user shall only have access to the information that their job functions requires. That means we cannot go and share all data to all users. We have to have some data restrictions. For example, a sales employee should not see all data like manager, and finance employee should not see all personal information like HR, and so on. That means if you are working with Excel, we have here again to split the main files into specific reports for specific rule. But in the other hand, most of the modern BI tools, they offer a feature called row-level security, RLS. Row-level security refers to restricting the rows of data a certain users can see based on the policies that we define. Using this technique gonna enforce the need to know principle and gonna make our life easier by just having one dashboard accessed by different types of users, and then based on the rule, they're gonna see the data and the informations that their job requires. Another benefit is reducing chaos. Let me tell you how we usually work with Excel. A data science will start exporting data from one source system, and he's gonna make a report called version 1 report. And then for other requirements, he's gonna make a version 2 report. And eventually we're gonna have a final report. And we have another data analyst working in different source system, and the same thing gonna keep happening a few times back and forth, and eventually we're gonna end up having different 6 versions of the reports. And if we scale this impact, you will notice that you are slowly poisoning your business, and the end user is gonna have to access different versions of the reports. And now if we ask how old is the data in our reports, we will get different answers. One version gonna be 10 days ago, another one 8, 4 and 3 days. That's mean we don't have single point of truth for our data, and that's why having modern BI tools gonna help us to eliminate such a chaos and gonna help us building a single point of truth for our data. Now let's have a quick history about Tableau. In 2003, Tableau was founded by 3 guys, Pat, Christian and Chris, as a result of computer science project at Stanford University. They focused on visualizations technique to analyze data inside databases. And then in 2019, Tableau was acquired by Salesforce in a deal worth over 15 billion. And for the last 10 years, Tableau was named as a leader in Gartner Magic Quadrants for business intelligence. Alright, so basically we have 3 very simple steps in the development process in Tableau. The first step, we connect our data to Tableau. Then in the next step, we start building our data visualizations to do data analysis by creating report, chart and dashboards. And in the third step, we share our work by publishing it. The 2 products to do these 3 steps are Tableau Desktop and Tableau Public Desktop. In many cases, the quality of our data is bad and not ready for analysis. That's why we add one more pre-processing step to prepare our data before we start building our visuals, and we can use for this step the product Tableau Prep. And in the last tutorial, we have talked about the 4 steps of Tableau development process. Now we're gonna do deep dive in the step number 4, where we're gonna talk about the different options that we have in order to share our reports and dashboards with others. If you want to share your visuals with your colleagues in your organization, then we have here few options. First, you can install Tableau Server product on servers using the infrastructure of your organization, and then you can start publishing and sharing your dashboard there. Then your colleagues can either use their web browser or they can use Tableau mobile app on their smartphone or tablets to view and interact with your dashboards directly from the server. The second option we can install Tableau Server product on cloud service providers like Amazon AWS, Microsoft Azure, or Google Cloud. And then you can publish your dashboard there, and the same thing here, users can use web browsers or Tableau mobile in order to access your work. The third option you can use Tableau Private Cloud Service. Here you don't have to install any Tableau server or anything. You will get everything prepared from Tableau team. You can start immediately publishing your dashboard there, and your users can consume it from Tableau Cloud. And now let's say you want to share your dashboards with everyone in the world and make it public, then you can use Tableau Public Cloud. You don't have to install anything, you can immediately publish your dashboard there, and users all around the world can use their web browser to access your dashboards and data, but they cannot use mobile app in order to access Tableau Public. And now to the last option that I really don't like to use. If you want to share your reports to individual users, you can send them a Tableau file with the format TWBX, Tableau Packaged Workbook, which contains your data plus your reports and dashboards. And then the users can view this file using Tableau Reader software installed at their PC. Charts. First, we ask the question, for which purpose? If we need a product for data engineering, then it's easy. We have only one Tableau product, and that is Tableau Prep. Now, if we need a product for data visualizations, then we can ask more questions. The next question, do we need to connect to server, API databases, or to cloud? If the answer is yes, then we have to use Tableau Desktop. And if the answer is no, then we ask the next question, can our data be public? If the answer is no, our data is confidential, confidential, then we have to use Tableau Desktop. But if the answer is yes, our data can be public, then we jump to the next question. Do our data sources contain more than 15 million rows? If yes, then we have to choose Tableau Desktop. But if the answer is no, our data sources have less than 15 million rows, then we jump to the last question. Do we need to have live connections to our data sources? If the answer is yes, then we have again to choose Tableau Desktop. But if the answer is no, then finally we can go and use Tableau Public. Alright, so if you follow those questions and this chart, you can easily decide when to use which Tableau product. Alright, so now with this we have an overview of all Tableau sharing products. So now the question is, when to use which product? So let me guide you in my decision-making process following this chart. Alright, first we ask all questions about the limitations inside Tableau Public Cloud. The first question, can data be public? If the answer is yes, then we ask the next question, should the data be frequently refreshed in the reports and dashboards? If the answer is no, then you can go and use Tableau Public Cloud. But if the data should not be public and should be refreshed automatically, then we have to think about private hosting. So the question now, do you want to manage the hardware? If yes, then you can use Tableau Server on-premises at your organization. But if you don't want to do that and you want to outsource it, then you ask the next question, do you want to manage the software on your own? But if the answer is yes, then you can use again Tableau Server, but this time it's going to be hosted in cloud service provider like Microsoft Azure in IaaS service model. But if the answer is no, you don't want to manage the software by yourself and you want to outsource it, then you can go and use Tableau Cloud as a SaaS service. As you can see, Tableau Reader is not in my decision-making process since I don't recommend it at all. So now, if you combine this flowchart with the one that we built previously for developers tools, you will get my whole decision-making process that I usually use when I start a new Tableau project. So if somebody asked you when to use which Tableau product, you can go through it and find the right combinations for you or for your company. All those materials you can find it in my website. Let's say we are a startup company and we want to host our own Tableau application and build the entire infrastructure for that reason. There is a long list of tasks that should be done. Of course, the first thing that we need to do is to go and buy some hardwares and configure them, like servers that will run the applications. And each servers need as well storage, so we have to provide additionally storage infrastructure like some hard disk driver and SSDs. Servers needs to be as well connected to the internet, therefore we have to provide as well all the networking infrastructure. Once we have all those stuffs, then we have all hardwares needed. The next thing that we need to do is that we're gonna go and start installing and configuring some softwares. Like we're gonna install an operating system, for example Windows or Linux, and many other middlewares. Once the operating system is in place, then we have to install and configure Tableau Server application. Once we have all software and hardware ready and running, it's finally now the time to set up our Tableau project, and we have to manage the following tasks. We have to start adding users to the Tableau server and map them to the correct licenses. We have as well to create schedules and tasks to refresh our data inside Tableau server, and then we have to start monitoring the Tableau jobs. Alright, so now we come to the big question that we have to answer. Who will manage what? The first option you have, if you decide to manage all these layers, that means we are talking about the on-premises model. So it's clear ownership. You manage everything from top to bottom. Hardware, the software, and the project itself. But now if you say, you know what, this is too much to manage. We don't have the money to buy all those stuff and hardwares at the start, and we don't have the time to take care of them and maintain them. Then you will start thinking about outsourcing the hardwares, where you're gonna buy a service from cloud providers like Microsoft Azure, Amazon AWS, or Google Cloud, so that they manage the hardware and you manage both software and projects. And this is what we call infrastructure as a service, IaaS, the first letter of each word. But now if you say, you know what, our IT team is very small, we don't even have the time to keep those softwares updated. Each time Tableau makes a new release, we have to install a new version of Tableau Server, which is really wasting our time, and we are not able to focus on our core business project. We don't have the resources to manage our own software. Then you start thinking about outsourcing the software layer. To do that, you can buy a service from Tableau. It's called Tableau Clouds, where Tableau team gonna manage everything for you, both hardwares and softwares. And this is what we call software as a service, SaaS. Now we come to the most important decision or questions that we're gonna make inside data source. Do you want to store an extra copy of your data inside Tableau? So here we have two designs for the data source. Either you're gonna say no, we don't need a copy inside Tableau, the data should stay where it is in the source systems. Then what gonna happen is each time your visualizations needs data, it's gonna send queries directly to the external database. And then the database gonna send the results back to your visualizations, so the data comes always fresh from the sources directly to your dashboards. This type of the connections, we call it a live connection. Or you're gonna say, yes, let's have a copy of our data inside Tableau. So a snapshot or subset of the data gonna be copied from the external database to Tableau. This copy, we call it an extract. And now each time our visualizations needs data, it's gonna send queries this time to the extract instead of the external database. And then the extract gonna return the results back to your visualizations. And since the extract is inside Tableau and very close to the visualizations, we will get great response time and very fast performance. This type of connection, we call it an extract connection. Alright, so now the question is, which connection type should I use in my data sources? The typical answer for this question is, well, it depends. Because here we have a trade-off between performance and data freshness. For example, if for you the performance is way more important than the data freshness, then you have to go with the extract, since the data gonna be stored inside Tableau in memory using the column store technique, you will get just great performance. But if you say, you know what, the data freshness for me is more important than the performance, then you have to go with the live connections in your data sources, because you will always get the fresh data directly from the sources in your dashboards. So as we learned, the Tableau workbook contains three things: the extract, the data source, and the visualizations. There is a file type for each combinations, depend on your requirement. For example, if you want to share only your data without anything else, no data source, no visualizations, then you can send an extract as a hyper format. But now if you say, you know what, I've done a lot of work in the data source. I built a data model, I renamed stuff, I did aggregations, I created a lot of new columns. So I would like to share that with my team, with my colleagues. And I'm not allowed to share my data with them. So in this situation, you say, okay, I'm gonna share the data source with my colleagues, and we call it Tableau Data Source, TDS, without data. Or you might be in other situation where you say, you know what, my colleagues don't have an access to the source systems, we cannot use the live connection. And you don't mind sharing your data as well. So now you can send them a package of an extract and the data source. So the file type here called Tableau Package Data Source, TDSX. So this type of file contains both of your data and your data source. And we might be in another situation where our colleagues or users, they are interested as well in the visualizations. So we can send them a file with the visualizations and the data source. And here again, we have the same situation. You decide whether you're gonna send with it a data or not. So if you don't want to send the data inside it, you can send a file called Tableau Workbook, TWB. And the last scenario, I think you already guessed it. If you want to send everything, the whole package, the extract, the data source, and your visualizations, then you can go and send your colleagues a Tableau format called Tableau Packaged Workbook, TWBX. Alright, so as you can see, Tableau did design different types of files for different purposes. So depend on the situation or the scenario that you have, you can share your work with your colleagues. Alright, so now generally speaking, we have two different types of workbooks. A workbook with data using extract connection, and another book without data using live connection. In one hand, in the workbook with data, you can send three different types of files. You can send only the data using hyperformat, or send the whole dataset with the data using TDSX format, or send the whole package with the format TWBX. And in the other hand, with the workbook without data, you can send only two files, the dataset without data, TDS, or the workbook WBX. And now you might have the question and you say, okay, which Tableau products should I use in order to open these Tableau files? Well, we have three Tableau products. Tableau Desktop, Tableau Public, and Tableau Reader. With the Tableau Desktop, you can open everything, you can open all these different Tableau formats and files, but with the Tableau Reader and Public, you can open only the Tableau Packaged Workbook, TWPX. Since Tableau Reader and Tableau Public cannot connect directly to the data sources and they cannot use the live connections. Alright, one more thing to understand about Tableau Workbooks is that Tableau uses two different types of data to store the workbooks. The first one is the metadata information. It will be stored in XML files. Metadata is data about your data. It describes your data. It contains all information on what have you done in the workbooks. Anything you click, drag and drop, or do while working with Tableau Desktop will be reflected in some way in the metadata. You can find information, for example, like column names, data type, data model, and so on. And the second type is the data itself, the actual data. If you load data inside Tableau, Tableau gonna store it in a format of hyperfile, where the data gonna be stored in column store methods in the memory of Tableau. It is like special formats for fast data retrieval. The Tableau architecture contains 4 different layers: the source layer, the desktop layer, server layer, and the consumer layer. We will start unboxing each layer one by one to understand their components, and we're gonna work with this architecture from left to right. So we will start by the source layer and we're gonna end up by the consumer layer. Alright, so now we have the source layer. The source layer is outside of Tableau and it contains the source of our data. So our data could be in databases like MySQL or Oracle, or the data could be in files like Excel and JSON, or even in the cloud like Amazon AWS or Microsoft Azure, or even in APIs. So our data could be everywhere. Alright, so now back to the big picture, let's jump to the next layer. We're gonna unbox the desktop layer. The first component in Tableau Desktop is the data source. Before you start building your visualizations, you must set up the data source. The first thing that we're gonna do inside the data source is to connect Tableau to our data. Tableau offers around 90 different data connectors, so we can connect Tableau almost to anything. Once you build the connection between Tableau and your source of data, the access information is gonna be stored inside the data source. For example, the path of the file, location of servers, username, passwords, or access tokens, and so on. So all this information is going to be stored inside the data source. Alright, so the two types of data connections in data sources are extract and live connections. So now we connected to data, we decided which type of the connection. The next thing that we have to do in the data source is to start building our data model. And we can do that by combining tables together using relationships, joins, and union. And you can do many other stuffs like setting the right data types, doing aggregations, renaming tables and columns, creating new calculations and filters, and so on. Alright, so now to summarize, the data source component in Tableau contains the following informations. We have the data connectors to connect Tableau to our data. We have the access informations where the locations of our sources is going to be stored. And as well, we can decide whether we're going to load an extra copy of our data inside Tableau. We call it an extract connection, or we're going to leave it as live connections in the data sources. And the last thing, we have the data model inside data sources, where we can combine tables together and do aggregations, or we can do some other custom stuff. Alright, so once we are done with the setup of the data source, we have the connection, whether it's extract or live, we have our data model, and everything is ready. Now we're gonna go and start building our visualizations. And Tableau organizes the visualizations in 3 levels. The first one is the worksheets. So we can use the data available in our data sources to build a single view, only one visual. It could be a bar chart, a pie chart, or a table view. And as you can see, each worksheet is connected directly to a data source. But in Tableau, you can build a worksheet from 2 different data sources by using very powerful combining methods called data blending. And this is a very unique feature in Tableau. You cannot find it in any other BI tools where the data in one visual can come from different sources. And once we have these different worksheets, we can go to the next level where we start combining these worksheets into one dashboard to show the different visuals in only one view. But keep in mind, if you want to do any changes in the visuals, you have to go back to the worksheets and do the adjustment there. And now we come to the last level, we have the stories. As you know, the main goal of doing data visualizations is to tell a story. So you can build like a sequence of worksheets or dashboards that works together in order to tell the users a story based on your data. Alright, so now you might ask me which visualization level is the right one for you. Well, if you have only one visual, then go with the worksheet. But if you want to build some kind of KPI to monitor process, then build a dashboard. And if you want to present your data and tell a story from it, then go and build a story. Alright, so now we have in Tableau Desktop both of the data sources and the visualizations, and these two components are contained in something called a Tableau workbook. So now the question is, after you're done building your data sources and visualizations, what can you do with this workbook? Well, you can share it with your colleagues in your team or department, and there is two ways to do that. Either you're gonna go and send a Tableau file directly to the users, or you're gonna go and publish the workbook to a Tableau server or cloud, and from there your users and your team can access your workbook. Alright, so now back to the big picture, the Tableau architecture. Let's talk about the layer on the right side, the consumer layer. There is different ways to consume Tableau visualizations, depends on the user's clients and on the tasks the users do. So we start with a very small group of users that they might use Tableau Reader to view and interact with Tableau visualizations, and they usually don't want to edit or create something new. For this group of users, we're gonna send them a Tableau file. As we learned, they're gonna need the Tableau packaged workbook TWPX. And we might have another group of users, usually they are your team colleagues, they want to build analyses on top of your work. They're gonna use Tableau Desktop to do that. For them, we can send any kind of Tableau files, depends on their requirements and their tasks. And now we have a big group of users or consumers that they can access Tableau server or cloud to view and interact with Tableau visuals. They can use their web browsers like Google Chrome and Firefox to access the content of Tableau server, and from there they can view, interact, and even edit the visualizations if they have enough permissions. Or they can use Tableau mobile app on their smartphones or tablets to view and interact with your workbooks, but they cannot use it in order to edit the Tableau visualizations. So for this group of users, you will not send them any files. First, you have to publish your work to the server. And here we have two options. Either you're gonna publish only the data source, or you're gonna publish the whole workbook to the Tableau server or cloud. And after that, you're gonna share the link of your workbooks to the users. And now to the last group of users that's worth mentioning, they are the static users. You can always export your data and visuals from Tableau Desktop and send it directly to the users as a PDF or Excel, so of course it's static and they cannot interact with it. Alright, so far in the Tableau architecture we talked about the source layer, we did deep dive in the Tableau Desktop and its component, and we understood the different type of consumers and the clients. In this video, you will learn about the Tableau server architecture, and then we're gonna do a deep dive into each server component of the architecture to understand how it works and what it does. And we start right now. The server layer contains mainly of three stuff. Two interfaces left and right, and in the middle we have bunch of server components. The left interface is the data connectors. They're gonna connect the external source systems to Tableau server components, and in the right side we have the gateway. It's gonna receive requests from different clients, and it's gonna connect it to Tableau server components. Alright, so now let's go more in details about the gate component. So in one hand we have requests come from different clients, like a login request from web browser or a publish request from Tableau Desktop. And in the other hand, we have different Tableau server components like the app server, VizQL server, and so on. And the gateway gonna be in the middle that knows how to forward the requests from different clients to the right server components. And the other task of the gateway is balancing stuff around. Let's say that you are working in multi-node environment where you have two nodes. When the gateway receives the first request, it's gonna forward it to the node number 1 since both nodes are free. But now if the gateway gets a second request, it's gonna say, oh, node 1 is full, let's process this request in node number 2 since it's free, and so on. Alright, so the gateway in Tableau server is like a distributor that knows everything.
You know someone like that?
Let's just say I know a guy who knows a guy who knows another guy.
So the gateway has two tasks. First, it routes the client requests to the right component, and second, it does load balancing if you are running Tableau server in distributed environment. Alright, so now we're gonna start talking about those Tableau components in the middle, and in Tableau server there is like different arts of components. We have servers, we have engines, and storages. And we're gonna start with the servers. As you learned in Tableau server, there is like different processes, the login process, publish, accessing a workbook, and so on. And in Tableau server, they designed different servers for different processes. So let's start now with the application server. The application server is responsible for different processes. Like as we learned, a user login request gonna be forwarded to the application server. Then the application server gonna check with the repository or an active directory, depend on your configurations, to find out if the user is allowed to access the server or not. And the other process the application server handles is the publish process, where the application server gonna get the publish request and it's gonna split the workbook into two files, the XML file to be stored in the repository and the Hyper file to be stored in the file store. And one more task for the application server is to render the server interface. All those little stuff that you find in Tableau server, like icons, images, projects, menus, it is the application server who render those stuff. So the application server is responsible for different processes, like the authentication and authorization process, the publish process, and rendering the server UI. But one process that the application server will never do is the visualization process. Alright, so now we're gonna jump to the next server. We have the VizQL server. This one gonna be interesting. Alright, so previously we talked about the power of visuals and how human brain transform text into visuals and images. The VizQL is like our brain. It's gonna do the magic by converting numbers and text into visual and images. VizQL stands for Visual Query Language for Databases. The founders of Tableau, Chris and Pat, they did invent this language. Let's say that you drag and drop something in Tableau, the VizQL gonna convert this action to an SQL query and then send it to the data server to get the data. Then the data server gonna send the results back to the VizQL as raw data. And now VizQL gonna do the magic by converting those raw data into visuals and images presented at your client. Alright, so the VizQL is the brain. It is very important Tableau component and responsible of the visualization process. And mainly it does two things. It's gonna generate queries from user action and it's gonna convert and transform the raw data into visuals and images. Alright everyone, so now we're gonna talk about the third one. We have the data server. So the data server is the one that knows everything about the data. It knows where to find the data, how to connect to it, and how to speak to it. The first task of the data server is to manage both extract and live data sources. If the data is inside Tableau, it's gonna send query requests to the data engine. But if the data is outside Tableau, it's gonna use the data connectors to send query requests to the external sources. And the data server knows how to speak to the sources. It acts like a proxy to the data sources, can speak many different database languages so that it sends a query request in a language that the database understands. And we have another task for the data server is to handle the data security. It checks if a user is allowed to see the data and do filterings if needed. And the data server manages as well the driver deployment. So the data server is the central data management component in Tableau server and the one that knows how to get data from the sources. Alright, so now let's jump to the next component. We have the data engine. If we decide to store our data inside Tableau as an extract, then the data engine gonna be the one dealing with it. Different components can send requests to the data engine. Like for example, the data engine can receive a request from application server to publish a new extract. Then the data engine can execute and create operation to create a new extract and store data inside it. The data engine can receive as well a query request from the data server asking for data. So what's gonna happen here, the data engine gonna find the correct extract, it's gonna connect to the hard driver, and then it's gonna pulse the needed extract from it. And at the end, the data gonna be sent back to the server. And finally, the data engine can receive a request from the backgrounder to update the content of an extract. So the data engine can execute an update operation by opening the extract and updating its content with the new data. So the data engine in Tableau is like any other database engine. It does different operations like it queries the data, it performs insert and update operations, and it creates new extracts. But only for the data inside Tableau server, inside the extracts. Okay, the next component is the repository. As you might already noticed, the repository was involved in every Tableau process. So let's talk about it. The repository stores many different types of data. Like for example, it's gonna store the workbooks that we publish to the server, but only the metadata part, not the data itself. So the XML files from the workbooks can be stored inside the repository. In the repository, we find as well the usage data. It's data that's gonna help you to understand the performance and the traffic about your project. Like for example, you can find the total number of active users inside Tableau server, what is the total view count by day, and you can find out the most used data sources in your project. Another type of data that you're gonna find inside the repository is the security informations. For example, which users are allowed to access your content, or which users are allowed to access our Tableau server. Alright, so as you can see in the repository, there is different types of data, and it contains as well huge amount of data in Tableau server, but it's very important to understand that is the data inside our dashboards and reports are not stored inside the repository. We have many other Tableau server components that's worth mentioning, like for example the cache server. It stores almost everything like images, icons, results of queries, dashboards, and so on. So if you start a dashboard that is already accessed before, the data gonna be pulled from the cache server. Another component is the backgrounder. In Tableau server, you can create a schedule to refresh the data inside your extract, and the task of the backgrounder is to check this schedule each 10 seconds and then trigger the process of refreshing the extract if the time comes. And the last component that I would like to mention here is the search and browse. The users of Tableau server, they can search for content, and this component is responsible for searching inside the repository and return the results to the users. Alright everyone, so finally we have the last puzzle, the server components. If we put it in the architecture, we will get the whole big picture of Tableau architecture. So now let's go and do a very quick summary. The source layer, it is the one that is outside Tableau and contains our data. And it could be anywhere, like databases or files. In the desktop layer, the developers can start connecting Tableau desktop to the data sources with either copying the data inside Tableau using an extract connection, or with the live connections to the sources. Then the developers can start building visualizations using worksheets, dashboards, and stories. And both of the data source and the visualizations, we call it a workbook, and we can either send it as a file or share it to the server. The server layer gonna host our workbooks, and we can find many components, like the data connectors to connect our sources to the Tableau server, and the gateway to connect the client request to the Tableau server. And we have the application server responsible for the login and publishing processes, the VizQL server responsible for the visualization process, and the data server is the one responsible for the data management. And we have another component like the data engine that's gonna handle the extracts. And in Tableau server, we have 3 places where the data gonna be stored. And we have the repository that contains many different data like the XML of the workbooks and the security objects, but not the data itself, because our data gonna be stored inside the file store as an extract. And we have the cache server that contains many different types of data to increase the Tableau performance. And the last one is the consumer layer. Here we found the different groups of users and clients, like the Tableau readers that needs only the TWBX files directly from the Tableau developers, and another group of users that they're gonna use Tableau desktop to develop new views. And we have the static readers that's gonna receive files like PDF and Excel, and then we have a big group of users that's gonna access Tableau server using either web or Tableau mobile to interact with the published workbook. Let's start with the source of our data. In Tableau Public, you can only connect files like CSV, JSON, Microsoft Access, and Google Sheets. The next component is Tableau Public Desktop. It is a free version of Tableau Desktop. It's software that you can download and install at your PC. So here we start by connecting Tableau Public to our files by creating a data source. And in the data source, we have only one type of connection. It is the extract. So the data should be copied from our files to be loaded inside Tableau Public Desktop. So there is no live connection option. And then after that, we're gonna start building our visualizations, or we call it vizzes. And now once we are done building the views and the dashboards using Tableau Public Desktop, we have here only one option to share it. And that is to share the whole workbook, your data and the vizzes, to Tableau Public. And Tableau Public is a free platform hosted from Tableau team to share the visualizations from the whole world. And once our vizzes are published to Tableau Public, they can be now consumed from users all around the world. And here we have few options. The users can use their web browsers to view and interact with your visualizations, or users can download the whole workbook, your data and the vizzes in different formats like Tableau file, TWBX, or Excel, PDF, images, and so on. And the last option of consuming your vizzes can be embedded into your websites and blogs. Okay, so now since Tableau Public is free, it comes with few limitations. At the source level, we can connect Tableau Public only to files. The data connectors are very limited and we cannot connect, for example, to servers. And in the next level, at the public desktop level, there is limitation in the data source. We have only one type of connections, and that is the extracts. So we cannot have a live connections to the sources, and the workbook itself, it can contain only maximum 15 million rows, and we cannot save the workbook locally at our computer. The only option to share it is to publish it to the Tableau Public. But there is like a workaround for that. I'm gonna show that in the next tutorial. Alright, so now let's move to the sharing level to Tableau Public. Here we have as well few limitations. For example, the total available size for each account is only 10 GB, and there is no way to refresh your data automatically. Each time you need new data, you have to manually republish the workbook with new data. And the third one, it's gonna be public, so there is no way to make it like private and to share it with only few people. You have always to publish it to the whole world. And now let's move to the final level. We have the consumers. The only limitation here is that you cannot use Tableau Mobile to access and interact with the visualizations. Alright, so we have three different types of data models at different levels of abstraction. First, we have the conceptual data model. This type is high-level representation of the data model without going in details on how the data model is implemented. It's like a map that shows the important entities and their relationships. And we usually use this type to explain the data models to business analysts and stakeholders to understand the big picture of the data. The second type is the logical data model. In this data model, we go more in details on how the data is structured and organized. We define in this model the attributes of each entity, and it includes as well constraints and more details about the relationships between the entities. This data model is usually used by database designers and developers as a blueprint for the implementations. And the third type is the physical data model. This type represents the actual implementations of the data model. It includes all the technical details about how to store the data, like the data types of the attributes, the primary and foreign keys, indexes, and so on. This data model is used by developers to create and manage the databases. Alright, so let's summarize. The conceptual data model shows the big picture of the data. The logical data model provides a blueprint for the implementations. And the physical data model shows how the data is implemented in the databases. And Tableau did adopt both the logical and physical data models in the data sources, but we don't have conceptual data model in Tableau. Don't worry about it, I will show you more details later. In Tableau data model, we have two layers. We have the physical layer, and on top of it, we have the logical layer. In the physical layer, we might have some couple of physical tables, and we can combine them in Tableau using two methods, either joining the tables or using union between them. And now let's move to the logical layer. It is the top level layer and provide us like an abstract to hide all the details in the physical layer. This is especially nice if we have a lot of tables in the physical layer. So once we are building our visualizations, we don't want to see all those tables in the physical layer, so the logical layer gonna provide us like an abstract or gonna hide all those details. So the result of merging the tables using join and union in the physical layer gonna be presented in the logical layer with single table, flat table, and we call it a logical table. So that means we're gonna have two logical tables. The first one gonna present three tables after doing the join, and the second one gonna present two tables using the union. But we still have in data modeling to connect those two logical tables, and in Tableau we have only one method to do that, and we call it relationships. And it's very important to understand that in the logical layer we cannot merge tables in one table. So after we connecting them using the relationship between the two logical tables, the table is gonna stay as it is and nothing gonna be merged. We just describe the relationship between the two logical tables. And now back to those two layers, both of the physical layer and the logical layer, we can find it inside Tableau data source. And as you know, on top of the data source we have our visualizations, and you can see in this example only the tables from the logical layer, and you can start building your visualizations using the data available from the logical layer. But sometimes as you are working with the projects, you build another data source with another data model. And here in this example, it's important to understand that not all logical tables comes from the physical tables, they could come directly from your source system. And now in order to build one visualizations from both of the data models and the data sources, we have somehow to connect those two data models or data sources, and we can do that in the visualization visualization level, where Tableau offers us the last and very unique method of connecting and combining tables, something called data blending. So by looking at this, you can see that Tableau offers us 4 different methods of how to combine and connect tables in different layers and different levels. So in the physical layer, we have the joins and unions, we have in the logical layer the relationships, and at the visualization level, we have data blending. Right, so let's start talking about joining tables. We usually have 2 tables, table A and table B. And if we want to combine them in one big table, then we can use join between them. The first thing to understand is that once we use join between 2 tables, then we have 2 sides. Table A gonna be the left table, and table B gonna be the right table. So now what gonna happen after we join the tables? All the fields from the left table will be at the output, and then all the fields from the right table will be added next to it. So joins combines the fields or the columns of 2 tables. So now in order to do joins, we need 2 things. First, we need the key field. It is a field that you can find it in both tables. And after that, we have to define the type of join, and we have to choose between 4 different types of joins. We have the inner join, the left join, right join, and full join. And if you know SQL, then you know those types. It's exactly the same logic. But let's have a quick examples to understand the 4 types of joins. And now I want you to understand how joins works in Tableau and what can happen in the background once we join tables. So we have the data source, we have the visualizations, and inside the data source we have the physical layer and the logical layer. In the physical layer, we're gonna join both of the tables A and B, and once we do that, Tableau gonna create one new combined table, A and B, in the logical layer. This table, we call it a logical table, which contains data from both tables. And then in the visualization layer, let's say we want to select the fields of F2 and F4. So Tableau gonna query the data source, and the data source gonna get the data from the new combined logical table AB, and then send the data back to the visualizations. So as you can see, the interaction between the visualizations and the data source gonna be at the logical layer. So the physical layer gonna be completely out of the picture. And that's simply how joins works in Tableau. Alright, so now let's talk about union. Let's say that we have 2 tables and both of them has exactly the same columns. Sometimes it makes sense to combine them in one big table, and we can do that using the union. So once we do union, what's gonna happen? The columns and the rows of the left table gonna be presented at the output, and from the right table, only the rows gonna be appended at the output beneath the first one. So union gonna combine the rows of 2 tables. And in order to do the union correctly, we have 2 requirements. First, both of the tables should have exactly the same number of fields, and second, the fields should have exactly the same data types. So as you can see, we don't need a key between those 2 tables. It's not like the join. So what is relationships and how it works in Tableau? It is completely different than joins and union. If we have in the logical layer 2 logical tables, A and B, we can connect them at this layer using the relationships. Think of the relationships as a contract between 2 tables. And when Tableau uses the data from those tables, it has first to check the contract in order to understand how to generate the queries. And now it's very important to understand that once we connect the tables using relationships, the tables gonna stay separated from each others, and Tableau will not create a new logical table. So everything gonna stay as it is without any changes. And here we just describe the relationships between 2 tables. So now in the visualization level, if we take the field F1 from table A and F4 from table B, what's gonna happen? First, Tableau gonna check the contract in order to understand how to generate the queries, and then it's gonna send the query to the first table, and then it's gonna send another query to the table B in order to get the data for F4. And then the data gonna be combined at the visualization level and not the logical level. Alright, so now let's talk about data blending in Tableau. But first, some coffee. Let's go. Alright, so now let's have this example where we have in the data source table A, and now in the visualization level, we want to use the data from the field F1. And you know by now, Tableau gonna send a query to the data source in order to get the data of the F1 from the table to show it in the visualization. And now since this data source was the first one to be queried and to be used, and Tableau gonna call it a primary data source, and in Tableau anything is primary gonna get the blue color. That's why you will see like blue icon indicates that this data source is a primary one. And now sometimes we are in a situation where we want to get the data from another data source. For example, we have another data source with a table B and we want to add the visualizations to show the data of F4. So what's gonna happen? Tableau gonna send another query to the second data source in order to get the data of F4, and then the data can be forwarded to the visualizations. And here Tableau gonna call this data source as a secondary data source, and it will mark it with an orange icon. And now in order for this to work, where we're gonna get data from two different data sources, we have somehow to connect them. And here exactly we're gonna use the very unique way in Tableau where we can connect data sources together using the data blending. And data blending can only be done at the visualization level on the worksheet page, not in the data source. So now you might ask how Tableau is joining those tables at the visualization level. Well, Tableau is using a left join. We cannot change that, sadly, it is fixed. Since it's like a left join, Tableau gonna get all the data from the primary data source and only the matching records from the secondary data source. So now to summarize, data blending is the method of combining data at the visualization levels from two different data sources using a left join. And this is very unique feature in Tableau. You don't find it in any other BI tool like Microsoft Power BI. You cannot, for example, there combine data from two different published datasets. In joins, the fields of both tables gonna be combined. So we're gonna take all the fields from the left side and beside it all the fields from the right sides. So the result, we're gonna get one big wild table. But in the other hand, in the unions, two tables gonna be combined, but instead of combining the fields, here we're gonna combine the rows of both tables. So we will get all the rows from the first table and beneath it all the rows from the right table. But both of them has exactly the same columns. So joins combines the fields and union combines the rows. And now let's see the big picture on how those four methods works. And let's start with joins. They're gonna connect two tables at the physical layer and they're gonna create completely new logical table in the logical layer where it's gonna combine the fields of both tables. And then at the visualization layer, the dataset is gonna create a query at the data source and data source gonna get the data from the logical table. And same thing for the union, you can create it at the physical layer of two tables and they're gonna create as well completely new table where the rows of both tables gonna be combined. And at the visualization, Tableau gonna send a query to the data source and the data source gonna get the data from the logical layer. And now to the third method of the relationships, we have two tables at the logical layer and Tableau will not combine or create anything. We are just describing the relationship between A and B. And at the visualization level, Tableau gonna ask the data source and the data source gonna get the data from the separate tables. And finally, the data blending, we have two data sources. The first one gonna be called the primary data source. The second one is the secondary data source. So first, Tableau gonna send a query to the primary data source and then another query to the secondary data source. Here it's important that the aggregation gonna happen before the data is combined, and we are combining the data at the visualization level using data blending. So as you can see, joins and union happen in the physical layer. In the logical layer, we can do relationships, and at the visualization level, we can do data blending. After connecting our data to Tableau and building the data model in the data sources, the next step is to check the metadata of the tables and the fields. Because once you connect your data to Tableau, Tableau gonna start analyzing the content of your data to make assumptions about the types and roles of each field in the data source. So Tableau can assign each field to data types like integer, string, date, and so on. Data types gives us information about the kind of data stored inside our datasets. This piece of information is very helpful for Tableau in order to understand how to deal with your data, which rules, operations, calculations can be performed. And one more thing that Tableau gonna do, it's gonna assign each field to a role. These roles gonna help Tableau building the visualizations. So the first set of roles, we have dimensions and measures. Dimension fields define the level of details of the view, and the fields with the role measure gonna be used for aggregations in the view. And we have another set of roles, we have discrete and continuous. These rules can help Tableau by plotting the visuals. So discrete fields can break the view to separate values, and the fields with the continuous rules gonna plot unbroken chain and connected values in the view. And I call all those informations about your field as a metadata in the Tableau data source. One more thing that I want to tell you is that those assumptions that Tableau makes about your field, is correct around 90%. So that means there is a possibility that those assumptions from Tableau are wrong. That's why it's very important after you build the data model is to have a double check on the metadata to check that all the informations are assigned correctly. Otherwise, you're gonna have bad quality and bad results at the visualizations. In Tableau, we have a bunch of different data types that we're gonna cover in this tutorial, and I group them into 3 categories. First, we have basic main 6 data types. We have the number whole, number decimal, string, date and time, and boolean. And the second group, we have roles, we have geographic roles and image roles. And the last group, we have advanced data types like group, cluster group, bins, and set. And this group contains special data types that's introduced from Tableau for data visualizations, and they are specially made in order to organize our data. And now we're gonna have a quick origin story. If you learn the concepts of data warehousing and business intelligence, you might already know that the core concept is the multi-dimensional OLAP, online analytical processing. So the concept says if you want to answer the business questions or do data analysis, first we have to build a data model that has the shape of a cube with multi-dimensions. It's something like this cube, and each cube has 2 informations. First, we have the dimensions of the cube, and the second informations, we have those cells. Those cells can store informations like data, numbers, and we call it measures. So each cube has 2 informations, the dimensions, and the cells, the measures. And now let's have an example. We have the cube of sales, and it has 3 dimensions. The first dimension is the locations, and inside the locations we have 3 members: USA, France, and Germany. Those 3 values are the member of the dimension location. And we have another dimension called time, and it has 3 members in the dimension: January, February, and March. And the third dimension, we have the categories. And now inside the cells of the cube, we have the measure cells. So now our cube is ready with the dimensions and measure, and we can start answering the business questions. For example, find the total sales in USA. So what's gonna happen? We can select the dimension location and filter the dimension to have only the member USA. This operation in the cube, we call it slicing the cube. And then we're gonna aggregate the measure, and we will get the total sales of 120. And if we have cube, we can do multiple operations like slicing, dicing, roll up, drill down, and pivot. So if you have such a cube, we can do data analysis and find fast answers to the business questions. In order to understand the concept behind them, we're gonna compare both discrete and continuous. And first, we're gonna start with the definition. So this concept comes from math, and they say discrete values are always separated, disconnected, distinct values. And continuous values are exactly the opposite. It's like connected value, a series or unbroken chain of data without any interruptions. So let's have an example. Think of discrete as you are counting from 0 to 10. So you start with 0, 1, 2, 3, and so on. So that means between 0 and 10, we have exactly 11 distinct values. But with the continuous values, we have like real numbers, which means between 0 and 10, we have infinite number of real numbers. So for example, we have 1.2, 1.3, 1.4, and so on. So with discretes, we have distinct values, and with continuous, we have a range of infinite values between start and end. Let's start with the definitions. Discrete values are disconnected, separated values, and continuous values are connected, unbroken chain of values. For example, in discrete, between 0 and 10, we have finite number of values. We have exactly 11 values. And in continuous, between 1 and 2, we have infinite number of values. Next one is about the colors. Discrete fields are the blue pills, and continuous fields are the green pills. Moving on to filters, discrete fields generate filters with a distinct list of all values available in the dataset. And in the other hand, the continuous fields generate a range filter that has start and end values. And next point is about the views. Discrete fields can generate the header of the view showing all possible values, and the continuous fields generate the axis of the view. Again, it's like a range of values. Then we have sorting. You can use discrete fields to sort your data using different options, but if you sort your data using continuous fields, you're gonna have very limited options. We have only ascending or descending. And finally, we're gonna talk about the purposes. The main purpose of the discrete is is to analyze a specific scenario like you are doing a deep dive analysis in a specific issue. But the main purpose of the continuous is to understand the big picture from the data in order to do, for example, trend analysis over your data. So these are the main differences between discrete and continuous fields. Alright, so now we have a field in our data, and in Tableau we can assign it to different data types. So it could be string, or boolean with true and false, or a date, and we have as well date and time, or a number, whether it's whole or decimal. And now next, Tableau can assign it to another metadata info, either dimension or measure. Any data type that is not a number, it's gonna be dimension. So string, boolean and date, all of them gonna be automatically dimension. We cannot convert it to a measure. And if the data type is number, we could have it as a measure or dimension if it makes sense to do aggregation. And next, Tableau can assign this field to the third metadata concept, discrete or continuous. If we have a dimension field with the data type string, it could be only discrete. We cannot convert it to continuous. Like in our dataset, we have the category, the first name, the country. All those fields are string, dimension and discrete. You cannot change it to anything else. The same goes for the data type boolean. It could be only dimension and only discrete. But now if we have a dimension field with a data type date or date time, as you saw in our examples, it could be continuous or discrete. We can have both. And now to the last one, if we have a field with a data type number, it doesn't matter whether it's dimension or measure, we can have this field as continuous and as well as discrete. Alright guys, so with this you have big picture for all those confusing concepts in metadata in Tableau. Let's say that in our dataset we have the following data points. So first we have to define how many clusters we want to build. So in this example we're gonna go with 3 clusters, and after that the algorithm gonna pick 3 points and we call them centroids. And then it's gonna assign the data points to the nearest centroid. So for this data point, it's gonna belong to the green cluster. And then it's gonna go to the next data point and calculate the length between it and the 3 centroids. And then it's gonna assign it to the nearest centroid. For this, it's gonna be the red cluster. So the algorithm gonna do that for all data points and assign them to the nearest centroid. So at the end, we're gonna have 3 clusters, the green, red, and blue. As you can see, the key means is really simple and easy to implement. Alright, so now let's say that we have the following data points in our visualization. We can use data sets to group up those data points. So sets can define your data based on specific criteria or selection into 2 groups of data. The first group, we call it the in group. In this group, you're gonna find all the data points that are included in the subsets of data. These data points are the members of the set. And the other group is the out group. This group contains all the data points that are not included in the subsets of the data. So that means the data points in this group are not the members of the set. So the sets in Tableau divide our data into 2 groups, the in and out groups. First, you connect your original data into Tableau data sources by either having an extract connection, where you're gonna load an extra copy of the data inside Tableau, or you can use a live connection between your data and Tableau data source to get data on demand. Then you might have different worksheets connected to the data source, and for the visualizations, they're gonna send a query to the data source, and then the data source gonna respond by sending the result data back to the visualizations and to the worksheet. So as you can see, your data is moving through different layers, different stations, and if you are not using any type of Tableau filters, the whole amount of data can be moved and processed from one layer to another layer. So for example, and those are just numbers to explain the concepts, we have in the original source of our data 30,000 records. That means the whole amount of data gonna be exist as well at the data source level. So there we're gonna have as well the same number of records, 30k, and then the same amount might be as well the results of your queries. So we're gonna have as well 30k records in the visualizations. So we might be in a situation where the source of our data might has a lot of unnecessary data. So it's gonna be really wasting resources and performance in Tableau if we are going to process the whole amount of data in each layer. So what we're gonna do, we're gonna go and apply different types of filters as your data is moving from left to right, from the sources to the visualizations. The first type of filters that we can use called the extract filter. You can apply the extract filter between the source of your data and the Tableau data source. You can use this type of filter if you are using the extract connection. So that means you cannot use the extract filter for the data sources using the live connection. So the extract filter will be used to filter the data before it even enter the Tableau data source. So for example, if we are using the extract filter, instead of having the whole amount of data in the data source, we might have only 20k of records. So the main purpose of the extract filter is to optimize the performance of loading data into Tableau. Sometimes you might be in a situation where loading the extract or refreshing the extract in the Tableau data source taking very long time. Here usually we go and create the extract filter in order to get rid of all unnecessary data and remove it before it even enter Tableau. And another benefit is optimizing the performance of your visualizations, because we're gonna have less data, less processing time in Tableau, and that's gonna result in better response time in your visualizations. So the main purpose of extract filter is to optimize both the loading time and as well the response time. And now let's move one step to the right side. We have another filter, we call it the data source filter. So you can apply this filter between the Tableau data source and the worksheets. So here again, the worksheets are sending queries to the data source, but this time the data source will not respond by sending everything, the whole data, but instead here the data source gonna filter the data first and then send the results. So here instead of sending 20k of records, here Tableau might send like around 10k of records. So here again, the main purpose of the data source filter is to reduce the size of data. So that means, and you know that already, having less data means less processing time in Tableau and better response time in the worksheet in the visualizations. And here we have another use case for the data source filter is to hide sensitive informations from the worksheets from the viewers. Alright, so now the question is, what are the main differences between the extract filter and the data source filter? Those two filters are really similar, but still we have some differences. The extract filter, as the name says, it could be applied only on the extract connections, while the data source filters could be applied in both extract and live connections. Extract filters could be found only on the Tableau desktop version, but the data source filter we can find it in both Tableau desktop and Tableau public. And the main purpose of the extract filter is to optimize both of the performance of loading the data and as well the response time in the visualizations, while the main purpose of the data source is to optimize the response time in the visualizations and as well to hide sensitive informations from the viewers from the worksheets. Alright, so now we're gonna move one more step to the right side to the next station, where the data is now inside our worksheets, and here we can use a very unique Tableau filter called the context filter. In Tableau, if you create a context filter, what you are doing is creating an additional layer inside the worksheets, where Tableau gonna take the result data from the data source and create a new optimized temporal table based on the filter inside the worksheet. And then the visualization is gonna get the data from this temporal new table or subset. And here the downside of the context filter is we are losing performance, because Tableau gonna spend resources and time in order to build this temporal table. So now you might ask me, why do we need context filter if we have a data source filter? We can easily use the data source filter in order to reduce the size, and with that Tableau don't waste any resources or time in order to build this layer, this extra table. Well, the answer for that is flexibility, because once you apply a data source filter, you are filtering all the worksheets that are connected to this data source. And in some scenarios, you cannot use the data source filters because you have different requirements and different focus in each worksheet. So you cannot set up one filter that is suitable for all worksheets. And here comes the power of the context filter, where you can fulfill all the different requirements by defining different filters for different worksheets, so you are flexible with the requirements, and at the same time you are reducing the size of the data to optimize the performance of the visualizations. And here you can go and decide for each worksheet whether you want to reduce the data using context filter or you want to have the whole data. So having this option gonna give you a lot of flexibility. So for example, in the worksheet number 1, we could use a context filter where we can reduce the number of records to 7k, and in the second worksheet, we could use a different context filter with different criteria where we can reduce the number of records to 5k. So the context filter is a really unique feature in Tableau, but don't forget we have here a trade-off between the flexibility and as well losing some performance, because Tableau have to create those temporal tables. So now by checking the big picture, that's how the first category of the filters works in Tableau. We have the extract filter, data source filter, and the context filter, and they share the same goal, to reduce the size of the data in order to optimize the performance of the visualizations. These filters are usually created from the Tableau developers and will not be offered for the users in the visualizations. And that brings us to the second category of the filters. We have the dimension filter, measure filter, and the table calculation filter. We usually offer these filters to the users to give them the power of slicing and dicing the data to focus on specific subset of the data. So these filters usually exist in the visualizations and they share the same purpose, to enable users to do analysis and to have better understanding of the data. And it's better to explain those three filters directly in Tableau. And now by looking to the big picture, you can understand that as we are moving from left to right, the importance and the priority of the filters are changing. For example, the most important filter is the extract filter, and as well has the highest prio in Tableau, which means Tableau gonna process it first. And the Tableau calculation filter is the least important and has the lowest prio. So that means Tableau gonna process it as the last one. So the order of the filters in Tableau are very important to understand in order to know where to apply which filter. So the order of filters in Tableau are defined like the following. The first filter to be processed is the extract filter. The next gonna be the data source filter. After that we have the context filter. Then we have the dimension filter. Next we have the measure filter. And the last in our list is the table calculation filter. So the top filter gonna be processed first, and as you are moving down the list, the filter gonna be low prio and will be processed as the last. So here again about the usage, the extract filter, data source filter, and the context filter is used to reduce the size of data, and the other three filters gonna be used by the end users for analysis and better understanding the data. And now the question is, where we can create those filters? The extract filter and the data source filter, we can create them in the data source page, and the other filters, we can create them in the worksheet page. Starting point, we call it in Tableau, is source sheets, and the action can be triggered by the user interactivity. How usually the users interact with our views using the mouse. So either by hovering the mouse on the data or by selecting or clicking on the data, and the last option is using the menu. So far we have defined for Tableau the starting point, the source sheet. The second thing we defined for Tableau, what gonna trigger the action, and the last thing that you have to define for Tableau is what can happen once the action is triggered. And here we have 6 different options or actions. The first one gonna be go to URL. That means Tableau gonna jump from Tableau to an external website. So that means the target gonna be here a website, not Tableau or not any visualizations. The second option is to jump or to go to another worksheet or to another dashboard. So here we are moving from one worksheet to another. Moving on to the third one, we have the filter action. What this means, the actions that we are doing at the source sheets, it's gonna affect the filtering in the target sheets. So anything that you are clicking on the source sheets, it's gonna impact the filter in the target sheet. And then we have another action called the highlight. So here again we have a target sheet, and this time any action that you are doing on the source sheet, it's gonna impact and gonna be highlighted in the target sheet without filtering the data. So that means go to sheet, filter, and highlights. You have always to specify the source sheet and the target sheet. And then we have 2 other actions where it's gonna impact the values of something. So here we have change set value. So anything that you are doing on the source sheets, it's gonna affect the members or the values of the target set. So this is gonna make the set very dynamic and interactive. The last one we have change parameter values. So again here, any interaction that you are doing in the source sheets, it's gonna impact the values of the parameters. So with that, we have now all the options that you can define as a consequence for the action. So as you can see, it's really easy. We have to define the source sheets, we have to define the trigger, and then we can define what can happen once the action is triggered. Alright, so now let's say that you have the following product table inside our data source, where we have informations like the product, prices, quantities, and so on. Those data are the original data that we can find inside the data source. And now let's say that we need a new field inside our data source to show the data of the revenue. In order to do that, we can simply create a new calculated field where it's gonna multiply the prices with the quantities. So now with that, Tableau gonna go and create a new field inside our data source to store the result of the calculations inside it. So Tableau gonna go row by multiplying the prices with the quantity. So for example, for the first row, it's gonna multiply 20 with 2, and Tableau gonna go and store it as a new field. Then Tableau gonna jump to the next row and do the same exact thing. So as you can see, Tableau is processing each rows individually and independently from each others. When the calculations is happening on one row, we don't care about the information that is present in the other rows. So Tableau gonna focus only on one row at a time. This type of calculations, we call it row level calculations, and the level of details we have it here is the lowest. So we have the level of detail from the data source. It's very important to understand that this type of calculations is the only type that will not go and aggregate the rows of the data source, and as well the only type that's gonna store the results at the data source. So that means Tableau will not go and calculate the result of these calculations each time you are using it in the visualizations. So it's gonna like pre-calculate it and store it in the data source, and the calculation will not be done on the fly. Alright, so now let's move to the visualizations, and let's say that I would like to show the total revenue of each product. And for that, we can use the function sum to summarize the values of the revenue, and we can go and add the dimension product to the view. And Tableau here gonna show only 3 rows in the view, a row for each product value. So that means we're gonna have P1, P2, and P3. Now this time Tableau will start summarizing and aggregating the rows in the data source, and that's gonna be at the level of the dimension. So for example, Tableau gonna start with the first product, the P1, and Tableau gonna summarize the first 2 rows from the data source. So we have 40 plus 60. Tableau gonna write at the output 100 directly in the visualization. Then it's gonna move to the next row. We have the P2. Here we have only 1 row at the data source, and the summarize of that's gonna be 20. And for the product 3, the P3, we have here 3 rows in the data source. So the summarization of 40 plus 25 plus 15, Tableau gonna have the answer 80 at the visualizations. So this time, as you can see, Tableau is not processing the rows of the data source one by one and individually. Instead, Tableau gonna go and summarize, group up the rows of the data source at the visualization level. This type of calculations, we call it aggregate calculations, and it's gonna be calculated on the fly. That means the result of these functions of those calculations will not be extra stored inside the data source. And now it's very important to understand the level of details of this new table that we have in the view. It has lower level of details as the data source, and the one who controls the level of details is the dimension that we have on the view. So the dimension that we use in the view gonna control the level of details for the aggregate calculations. And that's why we have another type of calculations. Because of that, let's say that we have another scenario where you say, you know what, I would like to control the level of details. I want my calculations to show the total revenue of each category. So here we can use different functions like the fixed function. So we're gonna have fixed category and then sum the revenue. So that we are telling Tableau, okay, find the total revenue, but this time it's gonna be fixed. It's gonna be connected to the dimension category. So let me show you what's gonna happen. Tableau gonna go and check, okay, what is the category of P1? It is the category A. And now the next question, what is the total revenue of the category A? So here Tableau gonna summarize 40 plus 60 plus 20, and the result gonna be 120. And here Tableau will not show the total revenue of the product P1, but instead of that, we are showing the total revenue of the category A. The same thing can happen for the next product. We have P2. It belongs to the same category, to A. So the total revenue of category A is again 120. And then the last product, P3, it belongs to a different category, this time to category P. And the total revenue of that's going to be 40 plus 25 plus 15. The output going to be 80 as the total revenue for the category B. So now who is controlling the aggregations? It's not anymore the dimension that we have on the view, but instead it's going to be the dimension that we specify on the calculations. This type of calculations, we call it LOD expressions, level of details expressions. And here the same thing like the aggregations, it's going to happen on the fly, nothing going to be stored inside the data source. Alright, so now moving on to the last calculation type that we have in Tableau. Let's say that after I got the result in the view, I would like to calculate the rank of the products based on the data that is displayed in the view. And in order to do that, we can use the function rank of the summary of the revenue. So what can happen this time, Tableau will not go and query the data source. Instead of that, Tableau can go and query the visualization itself. So here it's like we are aggregating the aggregation. So based on the value that is displayed on the view, we can find that the product 1, P1, has the rank 1, then P2 has the rank 3, and P3 has the rank 2. This type of calculations, we call it table calculations, and it is unlike all other types. It is based on the context and on the data that is displayed on the view, and it will not go directly and query the data source. It is as well computed on the fly. That means
means the result will not be stored inside the data source. And if you are talking about the level of details, it depends as well on the visualization. So it's going to depend on the dimension products. Alright guys, so with that we have now a big picture about the 4 different types of calculations inside Tableau, and we can see how Tableau going to compute the calculations and present the data at the end in the results. Alright, so there are 2 types of level of details, LOD. The first one is the one that we define inside our visualizations, we call it LOD Viz, and the other one that we define inside the calculations, we call it LOD Expressions. So now let's say that inside the visualizations, we have 2 dimensions, category and country, and we have the sales. And now in the right side, in the LOD, if you go and use the fixed function, so let's say that we have the fixed category, sum of sales. So what we have done here is exactly like you are building any other view. You need always a dimension and as well an aggregation. So with that, Tableau gonna go and let's say internally gonna create a hidden view with the dimension category and the aggregation sum of sales. So here, since we said it is a fixed function, Tableau will ignore the dimension that we have on the view. So it's going to work completely independent from the dimensions that is presented in the view. So that means the calculation going to be very static, and doesn't matter what you're going to do in the visualizations, nothing going to change in the calculation of the LOD expression. So what do I really mean? Let's say that in the view you have added a new dimension, let's say the product. Now you have made a change in the visualizations. We have now 3 dimensions, product, category and country, but the LOD expression will not change at all. It's gonna get exactly the same results. It's gonna has the category and the aggregation sales. So this is the main purpose of the fixed function, to make it independent from the dimensions that we have inside the view. So everything gonna be static, and this is exactly the main difference between this function and the other 2, include and exclude. So as you can see, building the LOD expressions, it's very easy. It's very similar as you are building visualizations in Tableau. As you are dragging the dimensions and the aggregations, here instead you have to define it inside the calculation, and always you have to define the dimensions and the aggregations. So it's really simple once you understand it. Now let's move to the next one, to the exclude. Okay, so in the visualizations, we're going to have exactly the same view with the 2 dimensions, category and country. But now in the LOD expressions, we're going to use the exclude, where we're going to have exclude category, sum of sales. So now what we are telling Tableau is to go and exclude the dimension category from the visualization. So that means in the LOD expression on the right side, we're going to get all the dimensions from the visualizations, and we will exclude now the category. So it's gonna remove the category from the dimensions, and that means on the LOD expression now in this example, we have the country that's gonna control the level of details in the LOD expressions, and Tableau gonna do the aggregations again depending on this dimension. So that means the exclude function will always remove the dimensions that is specified in the calculation. And here the big difference between the exclude and the fixed: exclude is depending on the dimensions that we have in the view. So let's say that we have added in the view another dimension. So now we have product, category and country. What can happen to the LOD expressions? Tableau gonna take all those dimensions and will only exclude the category. That means the calculation now gonna depend only on the product and the country. So as you can see, it is very dynamic and it depends on the visualizations. So the exclude will always react to the dimensions that are specified in the visualizations and gonna remove the dimensions that we specify in the calculation. Alright, so now let's move to the include function. It is exactly the opposite of exclude. So we're gonna have the same example. In the visualizations, we have the 2 dimensions, category and country, and now we're gonna say to Tableau, include customer dimension, and we're gonna have the same aggregation, the sum of sales. So now what we are telling Tableau with this calculation is to add 1 more dimensions to the visualizations, to add the dimension customers to the 2 other dimensions that we have inside the visualizations. So here again, it's very dynamic. Tableau gonna take the dimensions that are presented in the visualizations, the category and the country, and add to it a new dimension, the customers. And the function include is very similar to the exclude. It is dynamic, so it is depending on the dimensions that we have inside the visualizations. So again, the same example, if we go and add 1 more dimension, the products, we will end up having 3 dimensions in the visualizations, and Tableau in the LOD expressions gonna add 1 more dimensions to the expression, where we're gonna have at the ends 4 dimensions: customers, product, category and country. So that means in include function, we are saying do the aggregations in all dimensions that we have inside the visualizations plus one more dimension that comes from the calculation. So it's really easy, right? So now to summarize, the fixed function is very static. It doesn't care about the dimensions that we have inside the visualizations. It is completely independent. So it's gonna stay the same as you are changing the visualizations. But the exclude and include, they are depending on the visualizations. So exclude gonna go and remove one dimensions from the dimensions that are presented in the visualizations, where include gonna go and add plus one more dimension to the dimensions that are presented in the visualizations. So with that, we have now understanding how those three functions works in Tableau. So now we're gonna go back to Tableau in order to practice those three functions. So let's go. So the project's phases of building a house is very similar to a Tableau project. And here I'm going to show you now the different phases that I have usually in each Tableau project. So the first phase of each Tableau project, we're going to start with collecting and analyzing the requirements. So here first we have to understand the user requirements. Then we have to go and decide on which chart types we're going to use for each requirement. And then together with the users, we're going to go and draw the first mockup of our dashboard and as well decide on the colors. Then after we have understood the requirements, we can go and start building stuff in Tableau, and we start with the first step by preparing the data source. And here we have the following steps. First, we have to connect our data, then we have to build a data model, and then the last step of that, we're going to go and understand the data model and the data inside our data source. Then once we have a solid data source, we can start building our charts. And here we have different steps. First, we have to check whether we have all the data inside the data source, or we have to create a new calculated fields. And then once we create those calculated fields, we have to go and test them first before we start building any charts. And then after that, once we have all the data that we need, we can start building the charts. And then once we have the basic charts, we're gonna go and start formatting it by adding colors, removing grids, editing the axes and the headers. And now once we are building all our charts using the worksheets, we're gonna go to the last phase where we're gonna start building our dashboards. And now for this phase, you have to slow down and start planning everything step by step, and rushing in this phase will not help you at all. So first we start planning the whole structure of the dashboard by planning the containers. And once we have a plan, then we go to the next step where we start building the foundations. We start building the containers of the dashboard. And once we have a solid structure, we're gonna go and start adding the content to the dashboard. And after that, we're gonna have the step where we're gonna take care of the filters and the interactivity inside our dashboard. And then the last step of building a dashboard, we're gonna have the final touch by adding icons, like icons for the logo, icons for the filters, or for navigating between dashboards. Alright, so those are the main phases of building a dashboard in Tableau. And here of course my recommendations to take it step by step and don't rush things, otherwise you're gonna end up by chaos. And it's gonna be as well really hard to maintain the dashboard later. So don't rush building the dashboards, always take time in analyzing the requirements, understanding the data, planning the structure, planning the mockups, and by that I promise you're gonna deliver a professional work. And if you like my content and you want to support the channel, then I really appreciate it if you support, like, and comment. This really gonna help the YouTube algorithm. Thank you so much for watching, and I will see you in the next video. Bye.